Hi, it's Gadget UK here again, back with something super exciting. It always is for me. It's a battery pack that has been designed by Dennis Vandenbroek. It's a battery pack for a Sega Nomad. So the Nomad is the Megadrive Genesis portable handheld system. Hopefully you've seen the repair previously on my channel. If not, I'll stick a link up there. It came from Dennis at RetroGameRevival, and Dennis is the person who sent me this battery pack as well. So this is just amazing. I mean, look at this has been 3D printed and carefully assembled here. It's got the battery terminals here. I've got some brand new batteries. He told me what type of batteries to order in advance. I ordered those a few months ago. Sorry I'm sounding a bit nasally, I'm sneezing a bit here and full of cold. So you can see he's got like a USB charge port here, I think, for the charge of the battery packs, and a switch to switch it off and on. What I find amazing is the finish. Just look at the finish he's achieved with that. I suspect he sprayed it after he's smoothed it down, I don't know, but it just looks factory made. It is just amazing. So this is a prototype, and Dennis has sent me his original prototype. So I don't think he's got one that's assembled at the moment, which is, this is just amazing. Thank you ever so much, Dennis, for sending this. I'll stick a link down below to Dennis's channel, RetroGameRevival. Check his channel out. There's some great stuff on there. So this just like clips together. I'm not going to push it together now because I did that a minute ago, and it took me a minute or two to work out how to get it to pieces. You can see there's like a lip. There's a lip all the way around here, so the two quite snugly clip together once you've got the batteries in there. So I think the next thing we'll do, we'll open the batteries, get the batteries in there, see if we can find a USB charge cable. Let's just see if we can start to charge these batteries. Yeah, so as you can see, I went with some RS branded, RS Pro. Lithium ion 18650, PCB protected, 3.7 volts, 2600 milliamp hour. You can get higher currents and stuff, higher milliamp hour there, higher power. Capacity, I should say, but obviously it starts to cost you more money. I blooming hate this type of packaging. You can never get into the blooming thing, can you? Anyway, let's get that out. But as Dennis says, it pays to get a good brand. You know what you're getting when you buy from somewhere like RS online. If you buy something like this off eBay, yeah, your mileage is going to vary. You have more chance of getting dodgy batteries than good ones on eBay. But these, hopefully, should do the job. Hopefully these are the right ones. They look blooming big. Let's see if that fits in there. They're huge, aren't they, these? Massive things. My goodness. I'm hoping that does indicate... Yeah, it's got a positive there, look. So, without further ado, let's... seat that there. He's got a cable tie there, can you see that, to act as a strain relief, and then the two should just look at that. It clips together and it's seamless. Look at it. It looks like it's been manufactured by Sega themselves. It seriously does. Right, you've got a bit of paint missing there, and the screw head has come off there at some point, but you know what, that is just absolutely amazing. It feels pretty weighty with those batteries in there. So let's go and find a cable. So just using the USB charge cable there. This is from my PS4 actually. You can see the green LEDs on, so those should be charging now. It's going to take a number of hours to charge those up. Not sure what happens when it's finished charging. It'd be nice if that LED was visible somewhere on the outside. So the green LED you saw there was an indication it wasn't in the right mode. There's that switch on the side of this here. After switching it over, the red LED comes on and it's starting to charge. You can't feel any temperature there. There probably is a difference from ambient, but it is charging. And you can see here upside down 5.13 volts and 0.8 of an amp. When I first connected it up here, it was like 0.99. It was pretty much bang on an amp. So this is about, 40 minutes later ish. It's down to 0.8, so it's going to take a couple of hours, I think, to charge those batteries up. Then we'll give it a test. In case you're wondering how I was monitoring the current and voltage there from the USB, you can get these little devices. There's loads of them on eBay. You can see you've got a socket and a plug. So you can plug this into a USB charger, sort of thing you'd use to charge your phone. I think I use one for the Apple, actually, for an iPad or an iPhone or something. And then plug your charge cable in here. And I mentioned I used one from my PS4. I've since got a separate dedicated one. It's micro USB cable. So you plug that in there, and you've got the micro connector, which goes into there. So then if we just clip the shell back together here, switch that up, I think. That means that's on, I think. Now, I've not used this Nomad since I did the repair video last year. There's a few bits of dust on there, look. Just carefully wipe those off. So it's still looking pristine here. So what I need to do now is work out how this goes on. Well, I'm guessing this bit here lines up with there, because you can see there's cutouts here. I know that Dennis was working on different methods of connecting this up, but hopefully I should sort of, there you go, clip on, look at that, that's fantastic. So yeah, it adds a fair bit of weight, as you can imagine, but that is really sweet. So let's see if we can find an easy way to just flip this around here, switch it on. Now bear in mind we've not got a cartridge in, so let's stick a cartridge in. So let's stick our cartridge in, let's try and switch it on. Yeah, nothing. That's a bit weird. Switch that switch over. Yeah, I'm not sure why. I'm not sure what that switch does, but I had to switch that switch into the same position it was when it was charging. But as you can see, that has worked. That's fantastic. I'm going to go play some games on this, I think. So we're all charged up. Now this is the second day of testing, actually. The first day I played for probably about 2.5 hours, and it never went flat, but then I put it straight on charge after playing that long, and it was back up to an amp on the charger there, and it did take a good 2 or 3 hours to charge again. So I'm guessing I almost used the full capacity of the battery there. So if we just get this back on here. So I'll make a note of the time, and I'll report back when it's completely flat. So a quick update, it's been going since 11:35, it's now 1:13. So it's been going quite a while. So how long did that last, you ask? And the answer was around 3 hours, actually. It was just below 3 hours. And you could probably calculate that from the size of the batteries. We saw when it was charging, when you charge it and monitor via this thing, it shows an amp. When it's completely flat, it draws an amp, and it pushes into the battery at the same speed it pulls power out of the battery. It was drawing an amp the way it's configured, and the battery's 2.6 milliamp hours. You're going to get roughly 2.6 hours out of it. It kind of makes sense. So yeah, it was just below the 3 hour mark. I think the second time I tried it, it was about 2 hours and 40 minutes-ish, something like that. So yeah, you're not far off exactly what you would expect. So I'm going to do a couple of mods to this. Dennis sent me a photo, I'll show you in a minute, of this chip, where is it, this little chip here. And you stick a resistor between pin 1 and 2. And he gathered this information from the data sheet. It says that you can limit the currents that the PWM, the DC to DC stuff, draws. So I think it's set to an amp at the moment, so it'll be an amp all the time, constant current. And you can halve that by putting a resistor between pin 1 and pin 2. It's supposed to be, to calculate it, to halve it, you've got to have, I think it's 192k or 196k. The nearest I could get was 180k, so it's going to be slightly less than half efficiency there. But because the Nomad only draws 0.4 of an amp, well, less than half an amp anyway, so it should be fine. But the other thing I spotted while I was looking at this, can you see? We've got a bit of bare exposed there. It's just one of those things. I've done this myself lots of times when I'm building prototypes and things like this. It's very easy to do. Remember, this is a prototype. This is not how a final unit would be. So yeah, I'm going to desolder that black wire. It goes over here underneath that bit of tape, and just put a new wire there just to make sure there's nothing exposed. But it's just one of those things. As I say, I'm not being critical of Dennis's work here. I think this is absolutely amazing. He's done a fantastic job. But yeah, you want to deal with things like that. You don't want a black wire near a red wire when there's bits exposed on it. I mean, the red wire is not ever going to short onto that anyway, but I'll deal with it while I'm there. So I don't imagine this is going to be that easy to do. I could put a new piece of Captain tape there. I'm going to start by, hang on, is that a bit of solder I've just added on there? There's a bit of solder underneath it. Let's just pull that Captain tape off. There's some solder stuck on it, look. I'm going to start by desoldering the, I'm going to need to recut that wire because it's going to be a bit short, so we'll heat here and we'll just pull that wire off. Is it through the hole? Yeah, it is. I can always just unblock that and tuck it back through in a minute. You could argue the best way to do this is to remove it all out of the shell, but I think the board's stuck down with some double-sided pads or something. So let's just heat that. It's going to absorb quite a bit of heat, I think. There we go, that's out. Yeah, and you can see what I mean, it's just, you know, it's just the sleeve in there is just melted a little bit. So I got some pretty sturdy wire here, so we'll use this. But I'm going to stick that wire on after we've done the resistor. Having removed it is kind of helping out because, as you can see, we've got less stuff around here now, and this is the chip here, and it's between the two pins there. So if we just carefully bend this red wire up here, out of the way for the moment, if we can. I don't want to break it off. There we go. So it's just giving us a bit of clearance here to get our resistor in between these two pins here. It's going to be super hard trying to get a resistor in there. It really is. Yeah, these are the resistors. They are so small. I think they're 0603, is it? Right, so you're on the Supermicro. Can you see the resistor there? What I need to do now is hold that down with a probe and add a little bit of solder and flux to one side and then swap to the other side. Just to give you a bit of perspective, look how big my finger is. It's tiny, that resistor. It's going to be very difficult trying to hold that as I solder it. Hang on, there's a bead of solder there I've just spotted. Yeah, it's come out. So you're going to have to trust me, I've soldered the resistor on down there in between those two pins. I've put a brand new black wire down there, can you see? So there's nothing exposed, it's totally isolated. I'm just going to add a little bit of solder onto that point there. Again, I should be doing this outside of the case, but I can't get the boards out. And then we'll just try and feed that wire into there. I'm being careful not to melt the plastic case in any kind of way here. Just try and heat this one point and feed this wire in. It doesn't matter if it doesn't go into the hole. That's not so bad. And then we can just press that wire down a little bit. So we're all done. We've got our resistor, we've got our wire, and we'll just get a bit of captain tape there. I'll just put you on macro just so you can see that resistor before I reassemble it. Yeah, you can just about see it. Can you see it down here between those two pins? It's very difficult to get that to go in there. It's because it's got no clearance. That's the problem. You want to do this before you fit the board, really. Anyway, and the solder point here is okay. There's going to be some captain tape on there in a sec, and down here is no longer exposed. You could argue it's stuck out a little bit, but it's just the point here. You know, the sleeve in here is okay. It was exposed a fair bit up here. So I've got a new piece of captain tape under there. Just put that there. It's got this cable grip on here to act as a strain relief. So we'll just carefully get our batteries back in. Positives on the right hand side there. So it should be almost 100% more efficient now, if the data sheet's to be believed. There we go, clips together really nicely. Let's try it. Well, I think we can call that a fail actually, because if you watch the screen, see that flickering? I think it's not providing enough power. It's almost like it's cutting in and out, I guess. I mean, I haven't charged this in a while, but that's not the behaviour you get. It's really weird that. You might need to change that resistor size. Let me see if I've got any 100k, and let's go down a chunk there and see if that makes a difference. So I just used the soldering end to drag that resistor off there. Switch it on now. Sorry, I forget which switch it is now. Is it that one? Switch it on again. Yeah, there you go. So you can see that resistor was the problem. So let me see if I've got a smaller resistor. And when I say smaller, I mean in resistance size, not physically. This one's actually a bit bigger physically. It's like it might be a 1206 or something like that, I'm not sure, but these are 100k. So we'll just measure one of these actually before I fit it, just to make sure it is 100k. These belonged actually to Alice and Chalice. So thank you to Colin and Nathan for providing these. It's amazing how much I'm using those components actually. So same exact thing with 100k resistor there. And in case you're wondering how I managed that, I tombstoned it on the first pin, can you see? And then put a little piece of wire down to the second pin. on the other side of the resistor. So anyway, I'll remove that. That's not working. I'm not sure why. Obviously it's affecting the PWM, that. I'm not sure if it's to do with adjusting the duty cycle that's making it sort of cut in and cut out. If you had better capacitance in the system you're powering and an inductor, maybe you wouldn't have the issue. But anyway, it doesn't seem to work, so we'll remove that. I'm quite happy with it as it was, and getting enough battery life, to be honest. And you could always just upgrade the batteries. These are only 2600 milliamp hour. And whilst it puts the power into the battery at an amp to start with, and then it drops over time until eventually it drops to nothing, and the LED goes off, it draws an amp. That whole mod we did there with the resistor there is to try and divide that by 2, because, as I said, in the datasheet for the chip that Dennis has used there, it does clearly say that you can reduce its current draw from an amp to half an amp by, putting a 192, I think it was, K resistor in there. Now, the reason I think I got that flickering issue, and I think nobody else would perhaps have that issue, is when I did the repair to this, again, the link will be up in the top right somewhere, I ended up powering the screen, because this has got like a parking screen, hasn't it? One of those little composite screens. And I ended up powering the screen from the the power input here, but then powering the Nomad from the same circuit, because there was a 5-volt drop down on there, so I tapped the 5-volt for the Nomad from there, rather than using the regulator that's normally built into the Nomad. There's something like a 7805. I think it is a 7805 actually. And this was missing it. In the repair, the board was damaged, there wasn't a regulator, and I just did away with that and just used the DC to DC board that powers the screen. So what you've got here is DC to DC from the battery module here, powering a DC to DC on the screen, and it's just efficiency stretched too far. And what I mean by that is you've got PWM pulses for the power generated by this going into something that is generating PWM pulses. So of course you are going to get into a scenario where if your efficiency is too efficient on both sides, it just can't perform, if you see what I mean. You probably could if you added a load of bulk capacitance there, I suspect, and some inductors to deal with current dips and things like that. And I think that would probably solve it. But I think for anybody who's just got a normal screen in one of these, in fact, you can have the parking screen mod there. Whether it'll interfere with the screen, I'm not so sure. But what was happening here is you saw the screen was going off, it was flickering off. You could see it was still booting. The different coloured backgrounds were coming up with the Everdrive there. It wasn't actually working. It was just the screen cutting out. And I think it was just too much load on the DC to DC that was powering the Nomad and the screen. Yeah? Powered by the DC to DC on here, if that makes sense. So something Dennis mentioned to me, and I'd never thought of it. You could, in theory, power something like this from this as well. This probably would work, but I've just tried it. The connector here is slightly different. This is the smaller size. I'm not sure if there are any of the Model 2s that use exactly the same size connector as the Nomad. I suspect in my case, my rather dusty 32X, look at that, good God, this needs clean, I'll do that in a minute. Yeah, my 32X probably has the same size connector as that actually. Uses a smaller one, I think. So I've used this on and off for a few months. It's really, really good. It does take a couple of hours at least to charge up, roughly 2.6 hours, which is what you'd expect. And you get about 2.6 hours out of it, maybe up to 3. This perhaps drops a little bit because obviously I've been using it a fair bit, so battery life, it kind of just drops a little bit with each charge cycle. You could get a slightly higher capacity batteries. I've gone with the 2600 milliamp hour. That is typically one of the larger capacities you'll get for this, but I have seen 3000 and even beyond. I'm not sure whether I believe them, because some of those cheap Chinese batteries you see on eBay, yeah, they claim ratings that the device doesn't kind of meet. But overall, I think this is amazing. Dennis has done a wonderful job on it. I'm very, very pleased with it. Thank you very much, Dennis, for sending me your prototype. I'm not sure whether he's going to manufacture any of these in mass. It might be he builds 1 or 2. But bear in mind, he has a full-time job as well as a software developer, develops games for the PlayStation and stuff. So I would imagine, his time might be limited to be able to, manufacture some of these to order. We talked briefly on price, and I think somewhere around the £70-80 mark, maybe a bit more, maybe around the £100 mark. Now, you may think that's expensive, but try and buy a battery pack for a Nomad. If you just buy the one that goes on the back here, the official Sega one, that fits 4 or 6 alkaline, AA batteries, you'll pay between £100 and £200 for one of those. They're becoming super rare, and that was the incentive for Dennis to create this. He had the same idea as me. I spoke to him around the time when I got this and said, it would be really good if we can get a battery pack for this, and he said, I'm already on the job. I'm going to create a pack, and this is what he's come up with. So it is wonderful. It is wonderful. I briefly mentioned the point here about these contacts. So you can see the spaces there for battery terminals, and those would marry up with here. We had a bit of a brainstorming session between us, trying to think of different types of connectors that you could mount within here that would fit on the PCB inside and, you know, protrude a bit here, and then obviously make contact with these points here. I'm not sure what he's going to do with that, but he may revisit. But this fly lead coming off the back here, it's no big deal. I think it's wonderful. So yeah, an amazing product. Thank you very much to my patrons and my subscribers, anybody that posts comments and things. And a special thanks for Dennis, obviously, for sending that, and for sending this Nomad in a previous video that I repaired. I'll catch you in the next video.